All right, so we're talking about inscribed angles. The first lesson you talked about various pieces of terminology, the central angles, the radii, double line, I love that, diameters, the chords, and arcs. Now you're going to learn about a special angle called inscribed angles. Before we go any further, when you hear the word inscribed angle, what's it make you think of? You think inscribed angle, Jason?
Inscribed, so I just think ingrained.
Ingrained, I like that. So what's that kind of mean when it's ingrained? Kind of a synonym for that one.
It's like part of.
Part of, I like that. If they inscribe, you have a circle. If I inscribe something, that means it's inside the circle. That means that its points are touching the circle. It's ingrained, it's part of the circle. And that's exactly what an inscribed angle is. It's inside and it's touching the circle. So an inscribed angle is one whose vertex lies on the circle and whose rays intersect the circle. So they make that side. Now there's a nice thing about this is these inscribed angles. Inscribed angles are half of the measure of the intercepted arc. So they're half. Unlike the central angle. Well, you knew last time we did this, the central angle, it was exactly the same. If I had a central angle of 90 degrees, I knew its intercepted arc was 90 degrees as well. But for inscribed angle, an angle that's sitting on the circle, it is half of it. Alright? Well, let's try this example out. This is where highlighting or coloring in makes it visually easy to see. So if I have a measure of arc BC is 34 degrees, I know arc BC is 34. Mark it. This is 34 degrees. I want to figure out those rest of those angles there. Alright, let's find the rest. I will tell you this. Angle 3 is easy to figure out. Real quick, if you guys know this. So what is the measure of angle 3? What's that? 34. It is 34 degrees. But how do you know that? It's because of where the angle is at. If I outline this angle, is that angle sitting on the circle or in the center of the circle? Center or the outside? Center or the outside? Where's this angle at? It's inside, but is it in the center of the circle or is it sitting on the outside? Look at the angle. Is this vertex in the middle or on the outside? It's in the middle. This is a central angle. And we know that central angles have the same exact measure. So if this is 34 degrees, this guy's 34 degrees as well. We'll go ahead and label that in there. The next one that would be easy to see is what we're just talking about right now. And that's going to be angle 2. Or by angle 2, I mean angle 1, sorry. The measure of angle 1. Well, let's outline angle 1. Here's angle 1. There's one of its rays. There's its other. When we have angles like this, you see how the angle is sitting on the circle now? This is our inscribed angle. You'll hear me talk about the ice cream cone stuff too. You see that green part I just drew? Doesn't that kind of look like an ice cream cone a little bit? Well, the thing that's in between there, the ice cream, if you will, is its intercepted arc. And that's how I know the value. It's actually really similar when we give the central angle. But I know that that arc, this BC, matches up with that angle down there, angle 1. So is angle 1 34 degrees? Just like before? No. I mean, this is 34 degrees right here. This angle is much smaller. So there's no way that's going to be the same. But I do know this. There's a way. What do I know about inscribed angles? They're what? Half. I'm pointing the word half. It better be half. So how do I know that? Well, if this angle is right here, it's 34 degrees, the middle, the BMC, or angle 3. If I go down here, it's got to be smaller. How much smaller? It's half. So how do I figure out what the measure is? Well, I take that inscribed angle, and I divide by 2. Half of 34 is, you need calculation for this. Half of 34 is 17. So when I divide by 2, I get 17. So the measure of angle 1 is 17 degrees. Great. I'm going to go ahead and write that in there. 17 degrees. Angle 2. How do I figure out what angle 2 is? Does anyone have a plan of attack to get angle 2? So what do you got? Okay, she canceled that. That's on the record, microphone. She canceled that. Oh,
Not plugged in.
I don't think so.
Oh well. They have at least the words.
Yeah, I got the words.
Like the. Okay. Is that working now?
Huh?
Is that working now? Is it red?
You plugged in?
Yep.
Oh, yeah.
Okay.
We're on. Yeah, now we're back in. So, let's figure out what the measure of angle 2 is. Yeah, no audio. There's no talking going on right now. Alright, the measure of angle 2 is got an idea. How do we figure it out? Where's it at? Angle 2 is sitting up here. There's actually several ways to answer this one. How do I figure out what it is? Any ideas? No one is okay, sitting back on now. I like if we do this parallel lines, it's a great idea, alternate interior things. I can say that. Yeah, we don't know about parallel lines going on. That's a good guess, I like that. Let me put this out there. Okay, before I put it out there. What does that equal to 180? What all angles? 1, 2, and 3? Possibly. There's something we know going on about this. There's, what? Someone say something? This is one of my favorite angle relationships if you don't recognize this. But I do know something about 180 because I think you're possibly thinking about a triangle in there. Are you looking at a triangle? You're looking at these three angles, you're saying you got to do 180. I'll say this. There are several ways to answer this. One way is saying that this angle, if I think about this shape right here, this shape right here is a triangle. This angle is on the outside. It's an exterior angle. What do you know about exterior angles compared to their remote interior angles? If you don't remember this, it's fine. When I add these two angles up, what should they equal? Well, add these two exterior angles up, they should equal that one. Maybe that's why you don't remember that. Or this way, this is what a lot of people say is AC a straight line? How many degrees are a straight line? How many? 180. Well, this is 34, then what's this one got to be? Well, don't I have to do 180 minus 34? Yes, you do. If I do 180 minus 34, I get 146. So I know that this angle right here is 146. Now it's a triangle if you didn't see it this way. And triangle does add up to 180, so I can say this plus this angle 2 will equal 180. So I'll do that. So I'll do 180, I'll subtract it. 180 minus 146 minus the 17 in green. And that will tell me what a missing angle is. So what is 180 minus 146 minus 17? Probably more than one person answering this. Lots of you guys have calculators. Some of you look like you're 17. This is also 17 degrees. If you were another thing with the remote interior, I'd say, well, 17 plus what equals 34? 17 plus 17 equals 34. You could have also known that, I can't see what it is, MB, right here, that segment, is a radius. This segment is a radius. And these are connected by a chord. That made an isosceles triangle. You do one to 17, the other one had to be 17. Lots of various different ways to solve this. Again, the nice thing about this unit is like a puzzle. And you find one piece, use that information to find another, it just all maps onto itself. The more practice you do this, the better you'll get. Questions with number 1. Moving on to number 2. Similar situation going on here. Let's label what we can. All right, let's solve A first. Why not? Because it's the first letter in the alphabet. Let's roll. So I want to figure out what the measure of angle A is. How do I figure that out? Well, I'm going to go ahead. I'm going to outline angle A so I can see it a little bit better. There's one side of it. There's the other side of it. What do you notice about where those rays match up to? Look at this ice cream part, that intersected part. What do you notice? Nothing. You guys notice nothing? It's blue. Okay, it's roundish. Anything else? You guys notice anything else I looked at angle A matches up. What about that arc? Is this speaking a foreign language? Nothing? You guys don't notice anything here? What do you notice about from here to here? Is that a special name in the circle rules? Oh my god, you didn't know. You're withholding information. That's not good. Okay? It's a semicircle. What are the degrees in a semicircle? Oh, now we're flowing. So I know that this is 180 degrees. That angle is 180 degrees. Or that arc, excuse me, is 180 degrees. That's what a semicircle is. Well, how do I figure out what the inscribed angle is? What do I know about the inscribed angle, the angle that's sitting on a circle relative to its arc? It is... Thank you. Whoa. Gosh, that's good. It's a Monday. Everyone's saying I love that Super Bowl. You guys are amazed by those flying drones that look like stars. Blew my mind. I thought it was stars. Like Lady Gaga. Did you see it? You watch that part? It said Lady Gaga. How do you get the stars in it? She did. It was pretty sweet. I had no idea what she was doing. Then I found out they're robots. Dancing robots. Now I know. So, it is half. So to figure out what it is, I take that intercepted arc, I'm going to divide by 2, and that will give me my angle. What's half of 180? 90 degrees. And make sure you guys are participating, trying along. This always is the case. Anytime you have an angle that meets to the diameter like this, an inscribed angle, it goes to automatically go right ahead and say, yep, that's 90 degrees. So if you see that it matches up with 180 degrees, a semicircle matches up to this diameter, whatever you look at, I know that angle is automatically 90 degrees. Awesome. Let's try to figure out what B is next. So what is the measure of angle B? Outline angle B to help you visualize a little better. I'm just going to keep everything the same. Color, you can see it differently here. There's angle B. Its arc is right there. There's a problem though. Do we have the angle? No, that's what we're looking for. Do we have its arc? Do we have the arc for C? There's nothing there, right? So if I don't have the arc, I don't have the angle, I'm not going to be able to figure it out. Is there a way I can figure out what C is though, real quick? Can I figure out what the measure of arc C is? Derek? So let's say 180 by what? Not divide, by subtracting, you're saying? Yeah. He's saying, well, if this is a semicircle of 180, does that mean the other half is a semicircle? From here to here is a semicircle? Well, yeah, it is. So I can do 180 minus that 124, this piece I have right here, and that will give me what C is. So I'll minus 124. What is 180 minus 124? 56. 56 degrees. Great. So I now know that C is 56 degrees. Can that help me solve what B is? Yes, is the correct answer. How will I now figure out what B is? 56? What? Is this 56? All right, 56. Got it. 56 degrees. Good? I'm going to tell you it's wrong. Let's erase that out of there. What do I know about angles that are sitting on the circle relative to their inscribed arcs? Their intercepted arcs. Half. So if this is 56, what's B going to be? Half of what 56 is. So I'm going to divide 56 by 2, and I'll get a 28. So I know that this is 28 degrees. Question of those. Again, you'll get more practice with this. It'll be a lot easier to just figure out the pieces working around. Questions? Questions? Numero trace. Oh.
Again, inscribed angles are that relationship between the angle and the arc is important, and you're going to see it here in the next couple of pages.
course.
The measure of MOP is 118.
Yes, I can.
We want to determine the measure of NP. Okay, well, we're going to highlight the angle we're trying to find. NP. And whenever an angle is missing, I always like to look at the arc that is intersected. So, I'm going to take a look at this arc right here. If we can figure out the measure of that arc, then we can figure out the measure of the angle. You know, whenever an arc is missing, find the angle, look at the, whenever an angle is missing, look at the arc. Okay? If you don't have the measure of the arc, then you need to take the information you're given to find it. Okay, well, we can find this arc if we know what the rest of this circle is. If we can figure out what that purple arc is, then we can figure out what the green arc is. Do we know the measure of that purple arc? What is it? Very good, it's 118. Let's see, how do you get 118? Yeah, very good. The angle that is intersecting that purple arc is 118. And if you notice, is that angle in the center or on the edge? On the center. Whenever the angle's on the center, it's the same as that arc. Okay? So now that we know what that arc is, what can we do to find this big green arc? Very good. We know a whole circle is 360 degrees. Well, if we subtract this part of it, then we know the rest of it. We can do 360 minus 118, and what does that give us? 242. So we know this big arc is 242. Now that we know what the arc is, we can find the angle. So you have to ask yourself, is the angle in the center or on the edge? And again, we're finding this green angle right here. Is that green angle in the center or on the edge? Where is it? On the edge. So whenever the angle's on the edge, what do we have to divide the arc by? What is it? 2. So to find the measure of angle MNP, we take the arc and divide it by 2. So what do we get when we do 242 divided by 2? 121. There's the measure of NP. And when the angle's missing, look at the arc. If the arc's missing, take the information they gave you to find it. Because once you have the arc, you can figure out what the angle is. Kind of vice versa. The arc's missing, move the angle. Questions over there? Another important example in relationship with inscribed angles, we want to find the measure of each angle. And then we're going to figure out the relationship of the angles opposite of each other. So what angle do we want to find first? Doesn't matter. Okay. Let's find A. I'm going to highlight A. Again, when the angle's missing, find the arc that's in between it. Well, how can we find the measure of that arc? Well, here's part of the arc, and it says part of that arc's 100. Here's the other part, and it says it's 90. So what can we do with 190 to figure out the measure of the whole thing? What can we do? Add them. So 100 plus 90 is what? 190. And again, that angle is on the edge. So what do we have to divide the arc by when it's on the edge? 2. 90 divided by 2 is what? Or 190, I'm sorry, divided by 2 is? Same concept. What angle do we want to find next? We found A. What's the next one do we want to find? B. So highlight the angle. Again, when the angle is missing, find the arc. How can we find the measure of that arc? Same way as we do the other one. Part of it's 64, the other part's 90. What can we do with those measures? Add them together. 64 plus 90 is 64. Thank you. So again, when the angle's on the edge, what do we divide the arc by? What's 154 divided by 2? Same process for the next one. Let's find C. Highlight the angle. Again, when the angle's missing, look at the arc. What's the measure of that arc? Same way we did the last two. Nothing new. Yeah, 106 plus 64 is what? 170. Again, the angle's on the edge. 170 divided by 2 is what? We know the measure of angle C is 85 degrees. Right? Repeat the same process for D. And we all should be frozen by this one now. We'll highlight the orange. Here's the angle we're trying to find. Angle's missing. Look at the arc. What's the measure of that arc? 106. Divided by 2, what's 206 divided by 2? 103. Okay. So we found the measures of all the angles. Let's go ahead and fill them in to see their relationship. So A is 95, B was 77, C is 85, and D is 103. So take a look at the opposite, and is there something special about them? Notice anything? Okay? Perfect, the opposite angles added to 180. And if you notice, what kind of shape is this? I'll highlight it. How many sides does it have? 4. What do we call a four-sided figure? Four-sided shape. The general one. What is it? Quadrilateral. So if you notice, we have a quadrilateral. It's inscribed in the circle because all the vertices are on the edge. And if we notice, we did all this work and we found out that the opposite angles add to 180. You're in luck. This is true every single time. So whenever you have a scenario like this, you automatically know that the opposite angles are supplementary. And supplementary means add to 180. Any quadrilateral inscribed in a circle, the opposite angles add to 180 every single time. So instead of doing the same thing 4 times, you could have found A, and then did 180 minus 95. That gave you C. You could have found B, and then did 180 minus 77, and then C. That works out every single time. You have to know that because sometimes you're just given the quadrilateral and one angle, and you're asked to find the one across from it, and that's the only information you have. You have to know this fact to be able to find that missing